Hi guys, so I'm going to walk you through the net ionic equation worksheet to make sure you have all of those answers. Make sure you do it first, and then you can check your answers with this video. Okay, so this is the side that you're going to be looking at. And really, whenever you're doing these problems, first thing you need to do is balance. Okay, these are unbalanced equations. So double displacement usually are pretty easy to balance though. Sorry, it's a little blurry. Okay, so here we have two chlorines. Here we only have one chlorine, so I'm going to put a 2 in front, but now I have two sodiums, but only one sodium on this side. And so I have to put a 2 in front, and then I have two NO3s, which is fine because I have two on this side, one PB, one PB. So I'm good to go. And then all I really care about is the solid. Okay, so when I'm making this net ionic equation, I know on my products, it's always going to just be whatever the solid is. Okay? And then all I have to do is find these two ions on this side and add them together, right? So I know I have, I'm just going to write it in the order that is written here. So I have PB, and I have to figure out the charge on it. So sometimes that's a little tricky. So NO3, I guess there would be no way for you to know. So you'd have to know that NO3 has a -1 charge. It's a polyatomic ion, but there's two of them, right? So there's two -1s. So that would make NO3 -2, which would mean PB has to be +2. Okay. And then that's going to be aqueous. Put a little AQ by it. Okay. So AQ plus the chlorines also make this up. Okay, so I have two. This is tricky because you have to keep this big 2 coefficient. I didn't put a coefficient here because there was only one of them. So I have two Cl's, and I know chlorine always has a -1 charge. And then I'm going to put aqueous. And this is my complete net ionic equation because we only really care about what the precipitate is. That would be correct. So next one, we are going to balance it first. So I see we have two chlorines here, but only one chlorine here. So I'm going to put a 2 in front. Now my NAs are good. I have one CO3, one CO3, one Fe. So that's it. That's all I need. It's just that 1, 2. And then I'm really going to focus on this solid. So I'm going to write that first. So FeCO3 solid. Okay. And then I'm going to find my Fe in this on this side. So I'll put Fe. I have to figure out the charge. So it's with two chlorines. And I know chlorine is -1, but there's two of them. So that means that iron has to be +2. So I'm going to put +2 there. That is aqueous plus CO3. Okay. And we have to figure out the charge on CO3. It's a polyatomic ion, but this one you can figure it out because it's with two sodiums, and I know sodium is +1, so there's two +1s, so CO3 must be -2, and that, of course, is aqueous. Okay. Next one, let's go ahead and balance it. So we have two chlorines here, one chlorine here, so I'm going to put a 2 in front, and then I think we're good. No, we're not, because this one has one oxygen and this one has two oxygens. So I have to put a 2 in front over here to give it two oxygens. And that actually works out because then I have two hydrogens plus two hydrogens plus 2 times 2 hydrogens. So we're good to go. Okay, so now it's balanced. I really only care about this one. I never said this before, but we care about the liquid. Usually it's the precipitate that we care about, but if it's liquid, we care about that one. So this one is going to be 2H2O liquid. And then we're just going to focus on the two ions. So I have 2H, okay, I found that right there. And those have a +1 charge, and that's going to be aqueous. Okay. Plus the oxygen over here is going to be, oxygen is going to be -2, right? We know oxygen's always -2, and that's going to be aqueous. This one's kind of difficult because I never taught you the liquid thing, so that might be a little tricky for you. Number 4, we have to balance this one. So we have two potassiums here, only one potassium. So I'm going to put 2 in front, and then I have two chlorines, 1, 1, and then C2O4 is polyatomic ion. This is the one that's solid, so this is the one that we care about. So this is going to be Ca, I'm just going to copy it, C2O4, that's the solid. And then I'm going to focus on these two ions that make it up. So I'm going to say Ca, and that has a +2 charge. It always has a +2 charge, right? And I just realized this one's too hard because then it involves stuff that we haven't learned. So don't worry about number 3. I'll put that in the group chat. Okay. Anyway, so Ca is +2. So I'm going to put that there. That's going to be aqueous. Plus C2O4 is a polyatomic ion. Okay. That's, of course, aqueous. And we have to figure out what the charge is on this. So if you look here, there's 2 potassiums. We know potassium is +1, but there's 2 of them, so this must be -2. Okay, and we're good to go. This one over here, we have, is it balanced? Nope. So we have 2 PO4s on this side, 1 PO4 on this side. So I'm going to put a 2 in front. And then here we have 2 NO3s, but only 1 NO3. So I'm going to put a 2 in front. And then, oh, this one gets really hard to balance. So this is going to be a real pain. We have 3 zincs here. So we have to put a 3 in front here. Okay. I think we're good because then we're not good. No. This number is going to have to be a lot higher right here because this is 2 times 3. So this is 6 NH4s, and there's actually only 1 NH4 here. So this is actually going to have to be a 6 right in front of this one. Okay. And then we have 6 NO3s, which actually works out because we have 2 NO3s here times 3 is 6. So this is it actually. So this is the whole balanced equation, 2, 3, 6, 1. Okay. And then we want to focus on the solid, which is this one. So I'm going to put ZN3PO4 2. Okay. And then I'm going to find my ZN. So there's a 3 in front, so I have to remember to keep that there. So it's 3 ZN. And then I have to figure out the charge on zinc. So NO3 is -1. So since there's 2 -1s, okay, that means zinc has to be +2. And that's, of course, aqueous. Okay. Plus the PO4, which is right here. But you have to remember this 2 distributes. Okay, so there's 2 of them. So we put a big 2 in the front. And then we have to figure out the charge on PO4. There's really no way to know because you'd have to know what the charge is on an H4, and that's another polyatomic ion. I'll just tell you it's -3. I'll put that in the group chat so you guys have that. And that is aqueous. Okay, last one. Here let's see if it's balanced. So we have 3 chlorines, only 1 chlorine here. So I'm going to put a 3 in front. Now I have 3 lithiums, only 1 lithium. And then I have 3 OHs, 1 V, 1 V. So we're good to go. I only really care about this solid right here. So that's going to be my product. And then I have the V right here. I think that's vanadium. Let's see if I can get that focus. Come on, we're almost done. Okay, good. So we see that vanadium is with chlorine, but we know chlorine is -1, but there's 3 -1s, right? Because there's 3 chlorines. So that means vanadium must be +3, and that is going to be aqueous. Okay, plus OH. Okay, we have to distribute this. So there's 3 OHs, and we know that OH has to be -1 because it's with lithium, right? So lithium is +1. It always is. Because, on this chart, lithium is always +1. And so that means that OH must be -1, and that is, of course, aqueous. Okay, hopefully that was helpful. I'll see you soon. Bye.